Hello, everyone. Thank you for being here. Um, so I will present this paper, Climate Shocks and Economic Resilience, Evidence from Zambia's Formal Sector. It's a paper in partnership with Kwabena, my colleague at WIDER, and Evaristo. I'm not sure if Evaristo, yeah, he's there. And so if you have any technical questions about the Zambia Revenue Authority, you can ask to Evaristo. The rest I can try to help. Um, so the motivation of this paper was touched in some of the discussions that we heard in the main panels in the conference. So we listened a lot about fiscal crisis. We listened some discussion today about the climate crisis. Yesterday also the discussion about the poly crisis. And what we are trying to do here is to understand the effects of climate shocks on the non-agricultural sector in a low-income country. When we look to the literature on the impacts of climate shocks in low and middle income countries, most of the literature is focusing on the impacts on the agricultural sector. And one of the explanations for that is the lack of data. Usually we don't have good data for farms or good tax data in those countries. And this research is possible because of the tax data lab that we have in Zambia. And we are basically here trying to develop the same methodologies that we see in different papers, but asking a slightly different question. We have some literature about the impacts of climate shocks for the non-agricultural sector for developed countries, but the evidence for developing countries is basically restricted to upper middle income countries or large income countries. So we have some things about Brazil, some things about China, some things about India, Mexico, and that's it. So we don't know much of what are the impacts of climate shocks on the formal sector in low-income countries. So this is the motivation of this paper. What's the what we found here? Okay, so this is a summary of the entire paper. We studied the effects of climate shocks on farm performance and revenue collection in a low-income country. We show that extreme rain and extreme heat decrease farm performance, decrease tax on sales, and VAT collection. We show some heterogeneity analysis showing that basically the extreme rainfall affects all types of farms, while extreme temperatures affects only medium and large ones. And we show some evidence of mechanisms. So when we think about what we know from all the countries based on the literature, there are a lot of adaptation measures that farms take to mitigate climate shocks. For instance, if it's too hot, the farms can change the types of lights to LEDs, for example, that will make the environment not that hot. Or they can install AC, for example. But when we think about the formal farms in Zambia, we are thinking about farms with much more budget constraints that don't necessarily have the financial resources to do this kind of investments. And then it's also a country with loose labor contracts. So a lot of, there is some workers in the formal farms that don't have formal contracts. The workers with formal contracts, the contracts are not that strong, so the farms have some flexibility also to not respect the contract, etc. And then the contribution of the paper is we are the first paper to use tax data to study the impacts of climate shocks in the formal non-agricultural sector in a low-income country. And we show that in this context of low adaptation and loose labor contracts, employment and wage reduction is a potential adaptation mechanism. Let me show a bit about Zambia. I will jump this data part, so as I said, if you have questions, you can ask it to Evaristo. But basically what we are using here is the tax data for Zambia. So we have the entire universe of firms that report the sales, the purchases, and all the taxes, CIT, VAT, to the tax authority. Okay, but I will not go into detail to that. And then we merge this data set with climate data that's basically satellite data that's public. So you can just download different types of data, and you can merge the information at the seat or district level with the farm information, because we know the district that the farm is located. And then there is some characteristics about the Zambia climate. One very interesting characteristic is that the rainfall and the temperature in Zambia are very well defined throughout the year. So we have some months that's basically between November to April that you have more rainfall, and then the temperature is also slightly higher. And they also have the dry months that's basically between May to September. So our study will be using data from 2014 to 2022, just because it's the data that is available. So any question related to the longest drought in the past 60 years, that was last year, is not affecting any of the analysis that we are doing here. And we also show another interesting thing is that this pattern that we see in this big figure here is quite the same for all provinces in Zambia. So if you look to this same two variables, temperature and rainfall, the pattern for different provinces are quite the same. And there is also some geographical patterns of climate, temperature and rainfall in Zambia. We see, for example, that this area here, that areas with some rivers, areas with high level of rainfall, while these areas here, even though there is the dam also in this region, is an area with less rainfall. The methodology is quite simple. I just jumped this theoretical model. But the methodology is very simple. We create measures of extreme rainfall and extreme heat. And then we also take the lagged variables. And the idea is basically that not only the extreme rainfall and the extreme temperature in this month, but also the extreme rainfall and the extreme temperature in the past months affect the farm's performance now. Okay, so our data is at the monthly level, so we know the sales, the purchases, and the VAT of each farm at each month over the period of 6 years, so between January 2014 to December 2022. Okay. So all the estimations that we do is at monthly level. So all these measures of impact of extreme rainfall and extreme temperature, they are at the monthly level as well. And we are able to have a lot of controls. We control for farm characteristics, district characteristics, and province by quarter fixed effects. And the errors are clustered at the farm level. The dependent variables that we use here is basically sales and purchases, tax on sales, and why we would expect differences between, for example, the impacts on sale and the impacts on tax on sales is because a lot of products in Zambia are not taxable. So this is why, and then we have the value-added taxes. So snapshot of the results. An extreme rainfall month reduces sales by 4.17%, and the purchases by 5.6%. An extreme warm month reduces sales by 3.6% and the purchases by 3.2%. And the effects are much stronger for farms in districts experiencing 2 and 3 consecutive months of extreme rainfall. So what I mean is basically if a farm is located in Lusaka and Lusaka is experiencing 3 consecutive months of extreme rainfall, the negative effects on sales and purchases are much stronger. So there is a cumulative effect, also the shocks. And in terms of tax revenues, we show that an extreme rainfall month reduced farms' VAT revenues by 87.5%. Okay? And why these effects are potentially much larger than the effects that we observe on sales and purchases. We cannot rule out all the possible explanations, and we cannot address all the potential causes, mechanisms of that, because the data does not allow us to do that. But based on what we can say, it seems that firms, because also the level of audits and the regulations are not that strong, that firms can play especially with the purchases. Why? Because they can claim VAT, what they call VAT returns from the purchases. So basically, the idea of the VAT is that you're gonna pay the tax only on the net sales, right? So the products that the firms are buying, the firms that sold the products already pay VAT. So you're not gonna pay a VAT additional on that. So the firms can claim VAT back. And then when there is a month with extreme rainfall, the firms are claiming much more the tax on purchases than when the month has a regular rainfall. So the firms can, in Zambia, are potentially behaving strategically in the VAT reports to compensate the reduction in sales. So this is a not very easy results to understand, because we would expect that the total effect on VAT should be kind of a combination of these two. But no, it's much larger, because these auditing behavior, potential auditing behavior of the company. So we cannot be 100% sure about that, but this is the only explanation that we can have at the moment. And this is very important, because this is going to affect the tax collection in Zambia, right? So when the country has a hit by climate shocks, the firms will be reporting less sales, and at the same time the companies will be reporting more purchases, and then the VAT revenues will be lower. This is basically everything that I say in tables. So this is the negative effects on rainfall, the negative effects on heat. Then this is the cumulative effects. So when the country has 1 month with a rainfall shock, the point estimate is much lower than when the district has 3 months, consecutive months of rainfall shocks. And then this is the result on VAT, and we can see here that the effect of 87%. This is the heterogeneity analysis by firm size that I also mentioned before. And then the mechanism that I explained briefly in the beginning. So we basically, there is another table to show, but I prefer to put in this text. So basically, because the labor contracts are loose, the firms reduce employment and wages. So if you think about a country like Brazil, we have very strong labor contracts. It's very difficult to change your level of employment and the wages in the very short term. But it seems that in Zambia it's not the case, and we even show that there is some laws that allow firms to do that in Zambia. And that's it. We do a lot of robustness check, and this is the conclusions. Okay. Yeah, thank you.